As a part of this lecture, we'll try to understand user-defined functions. Before we really venture into this, let us try to understand a function. What is a function? A function is a module that performs a specific task. It takes the data as an input, processes it, and returns the output. As a part of the Spark, so far in what are the modules we have covered, we have seen so many functions. What are those? They are inbuilt functions. They are there as a part of the Spark. What are the examples? We have many examples. Count, we have show, we have create map, array contents. All these are inbuilt functions. All of them are there as a part of .sql functions package. Do you think always we would be having a inbuilt function to accomplish the task whatever we are doing? Not necessarily. There may be a situation which may arise. We may have to perform a specific task. That function may not be available as an inbuilt function. That is where user-defined functions come into picture. We'll try to see user-defined functions as a part of this lecture. One of the most important things that we can do in a Spark is define our own functions. User-defined functions make it possible for us to write our own custom transformations. As I said, some of the transformations may not be available as a inbuilt functions. By using a Spark, we'll be able to define the user-defined functions by using Python or Scala and even using the external libraries and use them. So what exactly the functions do is they take and return one or more columns as an input. At the end of the day, we are trying to manipulate the columns as a part of this whole transformation, right? So the functions which are defined by us, which are user-defined functions, will take and return one or more columns as an input. Spark UDFs are wonderful. They are powerful because we can write them in any of the programming languages like Python, Scala, and even Java. It is not necessary that it should be in a very complex way of writing the functions. It can be simple user-defined functions which can be written in any of the languages like Python or Scala. We can register them and we can reuse them. What they are doing is these functions operate on a data record by record. Though we are manipulating the columns, the data is operated record by record. Whenever you write a function and start using that as a part of a terminal, they are registered as a temporary functions. Whenever we have a temporary functions, we can use it within the context of that particular terminal. Outside that context, we will not be able to use it. To come out with the UDFs, we need to write a function, whichever is a function which we need to use as a UDF. Here we are trying to define a function. We are defining a function. Anyway, we'll see this example at the end of the lecture. We need to define a function. After we define a function, we need to test a function as well, whether the function is working fine or not. By the way, this is a Python function. We'll test that. Once we test that, what we got to do is we have to register them with the Spark so that we can use them on all our worker machines. If you don't register the functions as a part of the Spark, we will not be able to use them across the different executors. Assume these are the executors. To use them across the executors, we need to register them. In terms of registration, the function registered outside the SQL can be used only as a data frame function. Means you can use that as a part of the select, but we cannot use the functions registered outside the SQL as a part of the string expression. Then what is the solution? The solution is we can register that as a Spark SQL function. How to do that? We'll try to see that as an example. Look at the power of registering a function as a part of a SQL function. As we know, whenever we are trying to import a function, we are saying from PySpark.SQL.functions import. Most of the functions are available within the SQL package. Whenever the functions are available as a Spark SQL function, that can be used across the programming languages which are supported by the Spark. That is one of the important aspect of defining a function, which is a user-defined function for a specific purpose, and then using it across the programming language, across the executors. For example, now, what are the Python function which I just showed you that can be made available across the programming language, across the executors by registering it as a SQL function. One more important aspect is we got to be very careful with the return type. As you know, when we define a function, we got to provide the return type. Best practice whenever you define a user-defined function would be to define the return type. Whenever we are defining a function, specifying a return type may not be mandatory, but it is always a best practice. Why is that? I will tell you now. Assuming that you define a function and you will not define a return type. During the calculations, assuming that all the records in a data frame are int values. After the processing, this may become double. Now that you have not defined the return type as a double, it assumes, oh, something is a problem here. Since the return type is not matching with the input type, this will not throw an error. It will not throw an error. It will just give the output as null values. You will be wondering what is happening here. So whenever you define a UDF function, if it is throwing a null values, please check that you have provided the right return type. For example, if you want to optionally return a value, then you should return a none in Python and option type in Scala, so that it is taken care. Whenever you execute a user-defined function in Scala, whenever you define a user-defined function in Python, there is some difference. You got to understand that. As we know, Spark itself is written in Scala. When you write a user-defined function in Scala and use it as a part of Scala Spark, the performance would be much better as compared to defining a Python function and using it as a part of the PySpark. The reason is, as we know, Scala and Spark uses the JVM. But if we write a function in Python, what exactly happens is function need to be serialized and sent to all the executor nodes. The story doesn't end there. What also need to do is, what are the data which is there in each of the executors, that also need to be serialized and sent to the function, that is Python function. Now serialization of the function is happening, and also serialization of the data, the way the Python function understands, that is also happening. Then after that, Spark starts the Python processes and sends the data in a serialized way, and then the processing happens. Python returns the answer. Look at the overhead here. The serialization of the data need to be done in a way Python can understand, and it processes it. Then it will be sent back to the JVM of Spark. Whenever we define a functions in Python, this is one of the important aspects to be kept in mind. So let us take an example here. We are trying to create a data frame with range function and converting that into df, and then we are trying to define a Python function. What essentially it is doing is, it is trying to accept a value and then make it to the power of 3. That means 2 to the power of 3, that is 8, 3 to the power of 3, that is 27, like that it goes on. This is what the function is supposed to do. And now what we can do is, once we define the function, we got to test it whether the function is working fine or not. To use the function, we need to register a function. The way we can do it is import the UDF and give any name and register the function by using a UDF function. After that only we'll be able to use it on a data frame. After registering a function, we'll be able to use it as a part of any of the data frame. Otherwise it shouldn't work. This is a data frame what we have defined already. We can use this power3 UDF function on all the records of this data frame. Otherwise it wouldn't work. Now we have defined a function, we have tested a function, we have registered a function, and it is working as a part of the data frame. As I already indicated, this is registered outside the Spark SQL. Now this cannot be used across the languages. To do that, register a Python available as a SQL function. The way you can do it is, you can say Spark UDF, say register. This is the name of the function. This is the name of the function which is allowed. We have to specify the return type as well. So this is how you register a function, and once we do this, we'll be able to use this function as a part of the string expression. The final point, you got to be careful. This is the return type. You got to be careful with this. Registering, ensure that this data type matches with the data type of the input values in a data frame, so that you won't face any issues. It won't throw only null values. I hope you understood the important aspect of the user defined functions. Let us see all these things as a part of the hands-on exercises. Thank you.